This lecture video is for Chapter 5 of Maribeth Price's Mastering ArcGIS 5th edition. This chapter relates to queries. What are queries? We've already discussed this in previous lessons. However, it helps extract certain records from a map or table, and the records meet a certain criteria, such as all parcels with a value greater than $100,000. That would be aspatial, not spatial, or spatial queries, all parcels that lie completely within the floodplain. Those are two examples. It helps us select features of interest, selecting aspen stands from a forest vegetation layer, for example. And in this case, the cover type, the tree, is TAA, and that would be the type of tree that they're looking for. And then you can do statistics on the data that you collect. Exploring patterns. Are aspen stands randomly scattered or clustered? Do they occur in particular portions of the forest? And what are the distribution of the stand densities? These are just some of the questions that you can answer using queries once you find the data. Isolating for more analysis. Are there any mature stands with large trees with open crowns, and where are they? And in this case, the tree SZ96 stands for, or is looking for L, which would be large, and also a density of A, which would be open crowns. That's a multi-part query, SQL query that we'll do in GIS. Another question, what fractions of stands are intersected by roads? And what types of trees are adjacent to open stands? We'll use queries to determine the answers to these types of questions. Over what range of elevations do aspens occur? Do aspens occur above 1,500 meters in elevation? And then on the right it says raster query elevation greater than 15,000 meters. Attribute queries. SQL. Many databases use special query language called structured query language. We can write queries that work on multiple database management system environments. They can be saved and reused, and they're nearly always case sensitive. And this should be a repeat from previous chapters. And this slide actually is exactly a repeat. It's a SQL query example, and we have a population of 2010 greater than, that looks like 5 million. And again, they're case sensitive. Smith does not equal Smith. That's a duplicate slide. Queries as sets. Let T equal all students in the university. Let A equal all the students from New York. B equals geography majors, and C English majors. Queries are used to extract subsets, their records of interest from a set in a table. Multiple criteria may be used, such as geography majors from New York. Single criteria. T again is all students in the university, A is students from New York, B are geography majors, and C are English majors. Select students from T where home state equals New York. Select students from T where major equals geography. And you can see where if you're looking for geography it would be B, and then New York being A, it's this little sliver between the two. Double criteria. Select students from T, the entire area, where home state equals New York, which would be A, or home state equals New Jersey. And in this case, we don't have any from New Jersey, but we do have New York because it's in here. And because it's OR, they obviously can't be from both states. Select students from T, where home state equals New York and major equals geography. So that would be B and A. And it looks like they put some multiple criteria on the previous slide. And versus OR. Select students from T, where New York or New Jersey. Obviously in this case it's only A because there are no New Jersey residents in this image. Select students from T where home state equals New York and major equals geography. And that would be this little sliver again. Each condition is tested separately. If AND is used, then both must be true. If OR is used, then either may be true. Therefore, select home students from T where home state equals New York or major equals geography. Then we could have everything in B and everything from A combined. So it would be this whole area because it is OR rather than AND if we change that to an OR. Boolean expressions and OR are known as Boolean operators. Boolean operators are used to evaluate pairs of conditions. And versus OR again. Select students from T where home state equals New York and major equals geography. And this is what they're showing here. A is New York, B is geography, and since they said AND, both must be true, which is this sliver. Another AND versus OR. Select students from T where New York, home state equals New York, which is A, or major equals geography. That's why the entire area is selected. That's what I talked through in the last 2 or 3 slides ago. Select students from T where major equals geography, which is B, and major equals English. What is the answer? That should be pretty easy to figure out. Notice that it's AND. Select students from T where major equals geography or major equals English. And that would be also easy to figure out because of the OR. Select where students are from New York and major English. This one is a little bit more difficult to decipher. It all depends on where C is. If C equals T, then it seems to be pretty appropriate. If C is everything outside of A, then it isn't very difficult, or it is difficult to conceptualize, and there wouldn't be any. Select students from T where state equals New York or major equals English. Well, in this case, again, if English is this entire area same as T, then it would be everything within C. So here are the answers. Select students from T where New York and these are different questions. Where T equals New York, or from T where state equals New York. So let's see, A is New York and GPA greater than 3.0, and B is greater than 3.0. So it would be this sliver. And actually, so yes, they're saying A and B. Well, A and B is just this little area. It's not A or B, it's A and B together. Select students from T where state equals New York, so that's A, or GPA greater than 3.0. That means just one can be true, so that's an A or B. So anything within A or B. GPA greater than 2.0 and less than 3.0. And for our purposes, we're going to eliminate these bottom two because some assumptions need to be made. Here's a good visual actually of the Boolean operators. We won't be using XOR, but for example, A and B, so it has to be A and it has to be B, so it's this area. A or B, again, allows it to be everything. A XOR B would equal all of this on the outside and all of this on the outside. And again, we don't use XOR, so don't let that confuse you. A not B would be not anything in B but A. So it's very useful just to pull out things that are not any way associated with B. The order of operations, Boolean operators are similar to math equations. They have an equal order or precedence. Evaluation occurs from the left to the right. Parentheses must be used to change the order. This is an important slide. You must test each feature separately. Land use equal res or land use equals com. You cannot say res and com because none will be both residential and commercial. And in this case, they do it again with population. But the land use is much more easy to comprehend usually. This is a reminder or refresher of the wildcard using the asterisk. I've already talked about that. But you use an asterisk to look for MAC or MC. And here we could use an asterisk to look for a zip code that begins with a 0, which of course would be out on the East Coast. The like operator, using the like, we can use looking for a space, which is the percent, before and after a parenthesis, a D, and a parenthesis. It finds all the Democrats because they're symbolized by that parenthesis D parenthesis. It ignores D, O, N, and Danforth because there is no space nor parenthesis before the words or within the words. And again, that's how we would find New Hampshire and New York, but not Newcastle or Kennewick. We need to use that percent to get us wildcards. Especially this space right here is what helps because there is no space in Newcastle or Kennewick. Here's some information on spatial queries. Basic spatial relationships. There's intersection. Does the road cross the aspen stand? And in this case, the road crosses the orange aspen stand. Do two polygons share areas or boundaries? In this case, these two polygons share areas. There is in areas where they're abutment or up next to each other, they could share a boundary, but we can't get detailed enough information to tell that for sure. Containment. Is the aspen inside a geology unit? And is the road inside a geology unit? Nice spelling. Or proximity. How many aspen stands within 200 meters of a road? Which would be a buffer around the road, and then see how many stands are within those 200 meters. These are some of the spatial operators that we'll work with. These are, looks like most of them are listed here. There's quite a few of them, and they vary quite significantly. Intersect are within distance of, contain, completely contain, clementini, are within, are completely within, are identical to, etc. We'll discuss those in class when we're using them in the labs. Operators test relationships between the two layers at a time. The target layer is the one containing the features to be selected. The source layer is the one containing the features to be compared to. Select the aspen stands that are intersected by roads. So first of all, we have the aspen stands. Well, I guess they're actually showing it. These aspen stands are selected by the light blue because they are intersected by the roads, this thicker road, and then these forest roads. And then select the roads that are intersected by aspen stands. So this is a completely different query. We're looking for to select the roads. Notice how in the first one the roads is the target layer. In the second one the roads are the target layer. In the first one the aspen was the target layer. They're using these colors to help you understand this relationship. Intersection operators. Features intersect when any part of one feature touches, crosses, or overlaps another feature. We're talking about intersect up here. And then the lower set includes special cases of intersecting features. These are the containment operators: contain, completely contain, etc. They're a special area of the operator list. Types of containment. Contains, one feature lies inside another and may share a boundary. Oregon contains Columbia County. Completely contains is one feature lies inside another without touching the boundary. Oregon does not completely contain Columbia County, but it does completely contain Jefferson County because Columbia County is on the border. Within is the inverse of contains. Columbia is within Oregon. Jefferson County is completely within Oregon. This person, Alicio, and his co-authors defined a special set of topological relationships concerning containment. Clementini considers the boundary of a polygon to be separate from its inside or outside. This operator is equivalent to the standard operator except when the source feature lies only on the boundary of the target feature. An example. The Rio Grande lies on the border of Texas. The contains operator would select the Rio Grande. The Clementini contains operator would not select the Rio Grande because the state boundary is not considered part of Texas. Proximity. This operator tests whether the target features are within a specified distance of the source features. For example, volcanoes within 100 kilometers of an interstate. Other examples. Select counties that contain state capitals. And here we have these counties selected. Select counties that are within 200 miles of Denver. And you can see why those are selected because Denver is here. And notice that it's are within 200 miles of Denver. So parts of these must not be within the 200 miles. And it could be looking for, that's a tricky one because it could be counties in other states, which it does appear to be. Interesting. Oh, there's Denver right there. That's another city. Must be a different state. There's Denver. That's why it's pretty much equidistant all the way around. Select rivers that intersect, or counties that intersect rivers. Select rivers that intersect Texas. Select cities that are within 20 miles of an interstate highway and cities that are within counties named Washington. Scale and accuracy issues. When testing spatial relationships, consider that features are often generalized. Consider selecting cities that lie on or intersect rivers. A single point or line cannot adequately represent location at this scale. The selection becomes a hit or miss. One can use a buffer to allow a little room for error. So in this case, it looks as though the cities lie within the river, but in this case, it does not appear that the city lies on the river. Topological issues, or topology issues. In a real world, certain boundaries coincide. This condition doesn't hold true for many feature classes unless they have been specifically checked and corrected for logical consistency. And it's important to keep in mind that your datasets may contain topological inconsistencies that may affect your results. Here, Shannon County, which is in the purple dots, should contain the Pine Ridge Reservation, but it does not. Notice there are differences. About GIS, Chapter 5, Queries, General Information, Interactive Selection. Choose features by pointing to them on the screen. You can actually select them with your mouse. Select by attribute, based on the attribute criteria, or select by location. You can select features based on their spatial relationships. Selection tools. Here we have selection, select by attributes, and select by location. They are completely different. There's also a table of contents list by selection button, and it looks like this geodatabase on a layer. We don't use this button all that often in 3.11. View by selection. The visibility is shown. You can select them to be visible or not, and you can clear the selection. Clear selection only works on each feature, or the layer. Selection options give you much more finite control of the selection that you're going through. And again, everything, whenever we do selections, it'll always be in this light blue because we're going to keep it consistent for everybody in the course. Here are some viewed selected features with the table open and the map visible. We can see that New York, Pennsylvania, New Jersey are all selected. They're blue in the table and they're blue on the map. They're highlighted in both, which makes it easier for us to see that they're selected. In addition, it's also saying 11 out of 51 selected. There's a button here. This button where my pointer is shows both the selected and non-selected features. If I were to click on this button, it would only show the selected features. Using selected features. We will do this several times this quarter. Once a layer has a query placed upon it, all subsequent operations on that layer use only the selected features. And for this example, volcanoes are selected and then a buffer is created. The buffer uses only the selected volcanoes. The statistics only include the selected volcanoes. So notice that the buffer that was run after the selected volcanoes only includes these. It does not create a buffer around the other volcanoes. Clear selection, many ways to do it. It looks like that, that, and that. They are all very similar, although some work on all tables and layers and others work on just the one layer or table. some interactive selection. Click on a feature to select, hold down the Shift key to select more than one feature, draw a rectangle that passes through the features to be selected, or draw a circle with a specified radius. These are all different options for interactive selection. It is much more difficult to use interactive selection. It is easier to do it by using attributes. Selectable layers. Click to toggle selectability. In this case, all layers were selectable, and the person drew a square top left to bottom right to select everything beneath that, which brought up interstates and capitals. In the other example, with just states selected or selectable, a box was drawn from here to here, top left to bottom right, and just these 4 states were selected. That's why when you're selecting interactively, you need to be sure or cognizant of what you have as selectability so that you don't get this mess when you're looking for just this. Select by graphics. Use the drawing toolbar to create a graphic and then select by graphics. I have honestly never used this tool. It is much easier to select them by attributes or location. Speaking of select by attributes and select by location, here they are. Select by attributes. In this case, we're going to select by attributes in the layer states. Well, it states over here. On the right, it says select from cities where the population in 1990 is greater than 500,000. And this seems to be another repeat slide. Select where the beef cow in 92 is less than the beef cow in 87. Select from parcels where land use code equals 42 and the value of the land is over that 50,000 somethings. We're not sure what that value is. It could be acres, it could be dollars. Select from rentals where the rent is greater than 700 and the rent is less than 1,500. So that would give us a range. And just be aware that geodatabase tables use brackets and shapefile tables use quotes. Here's a select by location. The target layer is cities. The source layer is capitals, and the target layer features are within a distance of the source features. That is the special operator that we were discussing before. And to get to this, you would go to select by location. This is a drop-down menu here. And then this is part of this item over here. They've just blown it up. Intersect. This is showing an intersect the source layer feature, and they're looking for counties that intersect rivers. Select features from counties. So these are all the counties along rivers. Within a distance of, you can apply a search distance down here. This is a new item that they're showing us. We will actually use that in several of our labs. So it's similar to other select by location, but in this case we're using a search distance. Using a selected set. This is an advanced function that we'll also use. Select features from rivers, and then it says use selected features, and there's one feature selected. So we're selecting from rivers, but also we already have a selected state. So we're only selecting the rivers that are with intersect the source layer feature being Texas, which is why only the rivers that intersect Texas are showing up. It's using a selected set, so it's kind of a multiple selection, and we do this as well in 3.11. Within the same layer, select features from states, so we're selecting states. In addition, we're saying a selected state. The target layer features intersect the source layer features. So we have a state and we want to find all the states that intersect that state. So we're selecting the states that are surrounding what looks like Mississippi, Missouri, one of those. Selection methods. So selection methods, and this is available for all three types of selection: an interactive method, create new selection, add to current selection, remove from, select from current selection. A select by attributes is shown over here. We're going to create a new selection and then go through and create the selection. There'll most likely be more. Here's a Boolean two-step. If we're saying add to the selection, that would be an or. Remove from the selection, that would be a not. Or select from the current selection would be an and. So it makes it a little bit easier to comprehend than thinking about just these circles. A lot of the work is done for us in the drop-down menus. Applying selection methods. Create a new selection. Create a new selection where hearts equal yellow. Add to the current selection where hearts equal red. So now we have this top row, and we'll call this red, even though it's purplish on my screen. Add to current selections heart equals blue, so we'll say it's this row. So far we have yellow, blue, and red. Remove from selection hearts equal red. We remove red, we have blue and yellow. Select from selection hearts equal blue. So from our selection of yellow and blue, we're selecting just blue. And then select from selection where the hearts equal orange. There are none. Unless we're starting over again, and then it's a little bit different. But if this was done in progression, that's what we'd end up with, a whole lot of nothing at the very end. Combining. A FEMA problem. Distribute funding to quake-prone cities with large populations. Both a spatial condition and an attribute condition is necessary. Must be performed in sequence, although the order doesn't matter. Cities within 50 miles of earthquakes, and then cities with a population of greater than 500,000. This is an and operation. We want both within this distance of earthquakes and greater than 500,000 people. Spatial queries. Select by location. Notice location is spatial. Cities. Target layer features are within a distance of a layer feature. Cities within 50 miles of earthquakes. And that's all of them. All these that are selected. Moving along. Attribute query. We've already done the spatial. Select by location. Now the attribute. Select from the current selection. So of all these cities that are highlighted, which have a population of 500,000 or more. And that gives us this very few cities, list of few cities. Creating subsets from queries. Creating layers. We'll do this nearly every single lab. It's a common operation following a query. We create a new layer with only the selected features. We will also export features, which is similar to creating a layer, but it's actually creating a more robust item. Note that the new layer still refers to the original feature class, but with all the features, but it appears to contain only the selected features. So we have a state selection and states. If we selected these states would become part of a new layer. They would still be in the states layer, but now we have a new layer with just these selected states. Exporting. This is the one that we do the most. We'll go to Data, Export Data, and it creates an entirely new feature class rather than just a layer. Creating a definition query, we redefine a layer to include a subset of the actual features. Only the selected features appear on the map and in a table. It has no effect on the data stored on the disk, and it treats a layer as being smaller than it is, which speeds up processing time, and it doesn't require an additional data set to be stored. I don't think we use this, but it's something to consider if you're using large amounts of data. And that wraps up the chapter 5 from Maribeth Price, Mastering ArcGIS.